Well, hello and welcome to another Level 3 Cambridge Technical Engineering revision for Unit 3 Principles of Mechanical Engineering. So we're going to have a look at question 2, which is an inclined plane question with friction. Now, inclined plane questions are a sort of a staple diet of the physics and engineering examination paperwork. And they're great problems for students to consider the forces acting on objects, and also, again, a little bit more trigonometry. So let's have a look at the question and let's see how we get on. So the figure or the image shows a car of a mass 1,200 kilograms travelling up a rough hill. Now the rough is key because it's suggesting friction on an inclined plane at a constant angle of 5 degrees. The engine produces a driving force of P newtons in the direction of motion. Okay, so draw a diagram showing all the forces acting on the car. You may represent the car as a box in your diagram. Right, so again, I'm not asking you to draw to scale, but this is a point when I would suggest that you introduce a ruler. So we have our horizontal. I'm not going to draw 5 degrees because it's only going to be out there. I'm going to just exaggerate a little bit because it gives you a little bit of room to see what you're doing. Okay, and then we're going to put our box. So you can represent the vehicle simply by using a box. So let's have a think about the forces. The most obvious one is the fact that it has a mass and it has a weight. So it has a force acting directly downwards, which is the mass times the acceleration. So mass m times acceleration g. Okay, in this case it's going to be 1,200 kilograms, and that would be multiplied by 9.81 meters per second. Okay, so there's one of the forces that's acting on the box. Now one of the other forces, we'll work this out in a minute and we'll put a value in here because we may need to use it. One of the other forces is the fact that as this is pressing downwards, with every action downwards there's an equal and opposite reaction, but that force is being applied in this direction, perpendicular to the plane. So the actual force, the reaction, is in fact 90 degrees to the plane, in what we call the normal force. So I'm going to label that N, and you'll notice that that is also operating. So if I label this 5 degrees, then this is happening at 5 degrees. Right. This line, this is where I'm going to introduce trigonometry. This line is adjacent to this angle of 5 degrees. So if we think about it's an adjacent, and therefore we're going to use cosine. So this force here, the reaction force, is the mass times the acceleration due to gravity, but multiplied by the cosine of the angle theta, which is this. Okay, so here we have mass times gravity, and here we have mass times gravity multiplied by the cosine of the angle theta. Now remember, you're only getting 2 marks here. You're only getting marks for labelling and drawing these arrows. Okay, and there are a number of other forces. You've got the pulling force mentioned in the question. So let's add an arrow in for that, going in that direction. And we'll label that P, which is in newtons. We don't know what that force is yet. Again, the question hasn't asked you to label these values, but I'm doing that now because in this part 2, it asked me to calculate the maximum friction force acting on the car if the coefficient of friction, mu, is equal to 0.15. So I'm getting ahead of myself a little bit, preparing myself for this second question, because this one again is worth another 2 marks, so there's 4 marks in total on this page. Right, now looking at this, we've got an object with gravity acting downwards on a mass. We've got a reaction to the slope, which is in this direction, which is the mass times the gravity, but taking into account the slope times the cosine of the angle, 5 degrees. We've got the pulling force labelled, and then we've got friction. Now the friction force is basically, remember it said in the question, a rough surface. It's this here. And the friction is in response to the amount of force being applied to the inclined plane. So it's this amount of force being applied to the inclined plane. And of course, pulling action is in this direction, so the friction is always in the opposite direction. So the frictional force be that. I'm going to mark that with a friction force. So we're going to force little f friction. Okay. So I've got 1, 2, 3, 4 correct arrows labelled. I've additionally I've additionally labelled it so that I can deal with question part 2. Okay, just put a calculator in here because I want to sort of show you how I'm going to take this step by step. So just let me add that mu is 0.15, and then I'm going to work my way around the drawing. So we've got mass times gravity, so I've got a mass of 1200 multiplied by acceleration due to gravity is equal to 1172. And I get into the habit of doing your calculations in stages and then recording results. Okay, so you can go double back and check. So the next force I'm going to look at is the mass times gravity times cosine theta. I've already got that bit, 11772. So all I need to do now is type multiply the answer by the cosine of 5 degrees. And that gives me that value, 11727.2. Okay. So start that back a second. We've got 11727.2. Okay. And you notice the calculator just flipped there for a second. It's because I was just looking at this value here and what value we took for gravity, because if we do 1200 times 9.8, not 9.81, we do get a difference. We get 11760. And if we times that by the cosine of 5, again we get another value. We get 11715.25. Okay, so those minor differences, 9.8 or 9.81, do make a difference, but examiners are aware of the fact that students will be using, but read the questions carefully and make sure you're following whichever set for gravity, the value for G that they've picked. Okay, it's important. So if we just have a look at the front of the exam paper again, and you can see here quite clearly that you do a lot of exams, and you tend to sort of read through this very casually, but it does say quite clearly that we're using G as 9.8, and it's going to be referred to as lowercase g, meters per second squared. Okay, so we're going to resolve our answers using 9.8. 9.81 for me is a force of habit, it's a level of accuracy, but I'm quite happy with 9.8, so we'll proceed with using 9.8. Right, so let's bring in our 9.8 calculation. So we have a force downwards of 11,760 newtons. We have a normal force in a reaction to the slope of 11,715.25 newtons at an angle of 5 degrees, and therefore it's this force acting downwards on this slope that produces the coefficient of friction multiplication. So we're going to end up with mass times gravity times the cosine of theta multiplied by mu, which is 11715.25 times 0.15. So let's put that on there. Times 0.15 equals, so the force acting in this direction, and therefore the answer to this part of the question, calculate the maximum friction force acting on the car if the coefficient of friction is 0.15, the answer was B, 1757.28, let's go 0.3 newtons. That would be this force here. So now we've got 2 marks for 1, 2, 3, 4 appropriate arrows appropriately labelled, and we've also picked up 2 marks for our calculation of the maximum friction based on the mass acting downwards, its reaction to the normal slope, and the friction that this creates at 0.15. I hope that's helped you understand the question and do well in the exam.